To initialize a Pthread mutex, we may either use an assignment like this when we define the variable, or we use Pthread mutex init. And this function is used when the memory for the mutex is from malloc or calloc. And this one can be used if we allocate the memory, I mean the mutex on the stack, or as a global variable, for instance. And one case where you want to have it as a, may want to have it as a global variable is if you want to protect debugging out printouts with the mutex, which is a very good idea, unless you want to read confusing output. So then you can use the statement exactly like this, but maybe a better name for the mutex. Okay, so this here is a macro, so-called macro. Don't worry about it for this course, but it's something that can be used for storing basically anything, any text in it. Usually it can be used for instance, symbolic name for the maximum integer, that int max, for instance, and some other things. Null is another example. Okay, and this macro happens to be a constant expression, which means it can be evaluated at compile time, and therefore it is possible to use it with the global variable. Regardless how the mutex was initialized, we must call Pthread mutex destroy to free any resources used by this mutex. And if we used malloc or calloc to allocate the memory, we should also do free to return it to the heap. An alternative to waiting for a condition variable, as we saw before, is to use this version, which lets us use a timeout. But you are not allowed to use any timeout in the labs. Well, you are allowed to use it, but not for correctness. If you can find a way to make your program faster using timeouts, then that's fine. But your program should work without any use of timeouts. Okay, another thing, another primitive for synchronization is barriers. A barrier here is different from a so-called memory barrier that you may have heard of before, and which is used for low-level synchronization, and we will come to that later. The purpose of a barrier is to let threads execute in a more synchronous way. We initialize the barrier, that's the type, and we say how many threads will use this barrier. Okay, say we use 10 threads, so count here will be 10. Then, when these 10 threads call this Pthread barrier wait, the 9 first reaching the call will wait until the last, I mean the 10th in this case, will do the call, and then all of them will proceed after the call. So it's obviously very important that we know how many threads will be using a certain barrier, and afterward, after we have done it, we use destroy to return resources. When we initialize a sequential program, we may do like this, or we have a certain function in the API that lets the client call that function to initialize it. But maybe we have released the API before and without such an initialization function and want to add it afterwards. So then we can do it like this, and what this means is that this static tells the variable to remember the value it has until the next time any thread comes to this function. So even though this is a local variable and we set it to false initially and then we set it to true, so the next time somebody comes here it will be true. Now this does not work for a multi-threaded program. It says here might not work. Well, that's strictly correct, but possibly misleading. If this happens and only one thread is interested in this code, then it will work. But if multiple threads may reuse this, it may not work. I mean, it could, but it's just by chance. Since why? Well, checking this initialized and changing it, they must be atomic operations. So we cannot do it like this. Okay, instead we can use Mutex and take the Mutex, and then this will be as if it was an atomic operation. I mean, no one else is allowed to go here to disturb, and then we unlock it and everything is fine. But this looks like a little bit overkill, and in Pthreads there is this fourth primitive that I mentioned initially, namely Pthread1. I didn't say the name in case you didn't recall it. It's not your memory that is lacking. Okay, so what is this? It's a special data type that is used for calling a function one time. Of course, the function can be called from other ways, but with this variable, we pass the address of this variable and the function, and the first thread that comes to it will call the function, and the second thread, and so on, will either wait in case the first thread has not completed the call, and if the first thread has completed the call, they will just continue without calling this function. This funny thing here, left parenthesis, star, and right parenthesis, that's a parameter which means a function. And well, in C you can skip the parameter name. Not always, but when you just declare a type, or I mean not a type, but declare a function, then you can ignore the parameter names. So if you think this is weird, just forget it and learn about it in another course. Okay, thread attributes. I mentioned that we can say that a thread is joinable or detached, and that can be specified when we create the thread. By default, it's joinable, but we can say explicitly that it's detached from the beginning. And recall, if it's detached, it means that when the thread terminates, all its resources will be recycled immediately. Okay, so that's the first issue here. Another thing that we can do is to specify the stack address. And doing so may be useful if we see a risk that the thread's stack size by default is too small. What we can do then is to allocate memory using malloc, for instance, and use that memory as the stack for the thread. Or we can hope that the Pthread system will be able to use the stack size that we wish. So we can specify the stack size, but that's not portable. Okay, so that's it.